Alright, let's take a look at this one problem that is causing issues, and that would be this problem. So what I'm going to do, I'm going to snip a picture of it. If it will, I'll try that. Maybe I should not have. Let's see. I'm going to drop it right in here, and I'm going to take a look at it. This is a fairly simple problem when you recognize a couple of things here. First of all, the distance between these two are the same. This thing is sitting right off of the the Z axis right back there, and these two are the same distance. So with that, let me erase all these markings. And with one other fact, the fact that this 1,000 here, this 1,000 pound load is carried through this structure on these bearings and this piece of, say, welded metal and the shock mount. But there is no load carried in this member, in the upper members. So what you end up with is a two-dimensional problem. If you stand back here on the x-axis and look down it, this is what you're going to see. You're going to see a structure with a bearing sitting right here. You're going to see a structure with another bearing that's right back here. Comes out. These two connect. And then right there on this line, you're going to see what is essentially a shock absorber. I'll draw that as the, I'm sorry, let me erase this. It comes out to about right here. So here's your shock absorber. And your 1,000 pound force goes straight up. Well, as it turns out, there's nothing here pushing on this. There's no shock mount. The shock is mounted right here. So this is that point. These bearings are on this member, but these are zero force members, the upper one and that one. So I erase them from the drawing and end up with something like that. Now what I'm going to do is shrink this down, and I'm going to redraw this picture a little bigger. Here's my bearing. I'm out here to this. It's 1,000 pound load. Think between here and here it looks like I've got 12 inches, so let me just erase this because this is where I'm going to focus at. Put my dimensions out here. Looks like if you zoom in here, you'll see from A to B is 5 inches. So you have your mount point about right here. $5. And the shock mount sits back here. Maybe I'll make it go up a little bit. It is from this axis. So in other words, this is your Y. And then I'm drawing the Z. Now, this point is 2 back and 5 up. So maybe it is a little bit back around here. So it's 5 inches here. And it's 2 inches here. And this point is mounted from here to here. So let me see if I can turn my wrist. And that's it. So now if you look at the forces, these are bearings. This is a bearing mount here, and this is a bearing mount here. So I can't add a moment, but I can say probably going to have a force this way. Probably going to have a force this way. And I've got to have a force that goes up in such a manner that this force goes directly along. I've goofed up here. Let me see if I can shorten this thing or maybe reduce it. So this has to go along this axis, and it's probably going to push it because this is a, so if you want to look at it, this is kind of a bar, an axial loaded bar. This is an actual beam. So here we're going to look at this. I don't know what to call it, except I'll just say FBH. This is the member. This point is shared by these two. So I don't know. I'll just say FGF. How about that? But how about I'll just say FY, and my gut reaction says this has to be this way, FX. And that's the entire structure. You've got a couple choices here. One, okay, let's look at the geometry. Okay, maybe what I could do is copy this whole picture, move it down lower, and I'll work on the geometry. That way I won't mess up this drawing. So here, do a copy, move down here, and I'm going to work the geometry out there. Here, get rid of that thing. Okay, here. So let's work out the geometry here. I'll use a lighter color pencil. Oh, well, I thought it was. Looks like I'm stuck in one of those modes where it won't allow me. It will not allow me to change the pencil. You know what I'll do? Change it right there. Okay. So what we're looking at is a triangle that is 5 up. Okay, 12 minus 5 would get you 7 from here to here, and then add 2 more, 7, 8, 9. And so you're looking at a triangle like that. So what I'm going to do, I'm going to do this. I'm going to take this force right here. I'm going to slide it down and put it at point, I forget what that point was labeled. That's labeled B. Doesn't matter what it's labeled. So what I'm going to do is I'm going to copy this again. Copy. And I'll just copy it down here below it. This time what I'm going to do to it, I'm going to do this. I'm going to go back. I'm going to take this off. I'm going to take this, take that off. Put it to right there. So if I were to look at this, okay, 9 squared plus 5 squared, and the square root is the length of this member right here. Let me do that up here. And I do not have Octave launched. And I'll get myself 10.296. There's other digits, but I'm just going to let it 10.296. Oops. So what I'm going to do now is I'm going to use that, come back down, and say this force can be broken into an x component, which is, okay, look back at the drawing, 9 over 10.296, I believe that was the number, 296, times FBH. Y component would be 5 over 10.296 FBH. So now I've got a simple situation here where first I could go in and sum the moments about this point, which I guess I'll call it F, equals 0. I'll make that positive, which tells me I've got 1,000 pounds at 12 inches over. And then I've got, what I've really got here is I've got this. I've got a real light load here, creates no moment. And I have this component, which is the Y component, which does create a moment. And that's all I've got. No moment, no moment, no moment. So all I've got now, this is, if that's 5, that's 7 inches to here. Going the other way, the Y is 5 over 10.296 FBH. And the moment arm, what did I say? It was 7. Therefore, FBH would be 12,000. Okay, moving that to the other side, multiply it times 10.296 divided by 5. Oh, and divided by 7 as well. And Okay. 5 divided by 7. 3529 equals about 3529. Here. .9. Yeah, let's just make it 3530. So that's how much the shock is holding up. At this point, all you do to finish out the problem is sum the forces in the x direction, sum the forces in the y direction, equals 0, equals 0, and you work them out. Okay, in the x direction, you're only going to have this force and that one. In the y direction, you're going to have this one, and that one. From each of those, from sum of the forces x and y, you'll determine these two loads, and you're done. These two loads are at the bearings back right here and right here. As it turns out, they'll be split evenly because this is the 10 inches. They'll be split evenly amongst F and G. This has no load, this member has no load, that has no load, and that one has no load. And that's how you solve that. That's a fairly, once you see that these members have no load, it's a fairly simple problem. So I'll stop the video and drop it on YouTube right now.